inverse of the trig ratios. And to talk about the trig ratios, we need to go back in time a little bit to talk about why things get restricted. And we see that the sine and the tangent act alike in their periods, and the cosine is different. And we've seen that before, where the sine and tangent kind of act alike, and the cosine is different. But why do we have to restrict these? What is the purpose of these restrictions? Well, if we go back in time and look at our sine graph, here I have a sine graph, we know that it's a function because it passes the vertical line test. So I can take my vertical line and move it anywhere, and it hits only one point at a time. But we also know that for there to be an inverse, it has to pass the horizontal line test. And look what happens when we use the horizontal line. It gets hits everywhere that there are more than one. So this thing doesn't have an inverse unless we restrict our domain of our original function, which means we will have only one x value and one y value, and they correspond to each other. Okay? So that we restrict it so it passes the horizontal line test so we can have an inverse. And if we look at our inverse, and before we take a look at it, I'm sorry, we have to take a look at the two ways that we write it. Arc sine and the inverse sine are the same thing. If we go back, we talked about this is not the same as 1 over sine. This does not mean the inverse. It means the opposite operation of sine, which is not 1 over sine, because 1 over sine is the cosecant. All right, so there's your notation. Our domain now is -1 to 1. Why? Well, if you recall when we did the restrictions over here, that our domain was from here to here, and our range was from here to there. Well, what happens when we find an inverse is the domain becomes the range, and the range becomes the domain. So they just switch when you do the inverse. So our range becomes the -pi over 2 to pi over 2, and our domain is the -1 to 1. Okay? So, and this function gives the angle for the sine value. So if we know a value, we can give. And the way we read this is the angle whose sine is x. And we could write arc sine, but that's how we read it when we're trying to find the answers. The angle whose sine is x. Now, our cosine is the same dealio. Vertical, horizontal line test, all those happen. But why does the cosine act different? Well, from here to here, we're given all the positive numbers from 1 to 0, and from here to here, you're going to get the negative ones. If we went and did it like the sine, we're going to have the positive ones, and then we're going to have the positive ones, and that doesn't help us. We want to have one of each, where all the positives are. And so the cosine goes from 0 to pi. And so then, again, our range is from here to here, and our domain is from 0 to pi. And we switch when we do the inverse of it. So there's our inverse of it. And same reasoning as that we had with the sine. Now, if we look at the tangent, well, in the tangent, if we do the same thing that's one period of tangent, because the period of tangent is pi, not 2 pi like the sine and cosine. So if we limit it to being one period, we're going to get all of our values. Now we got to be careful with our range of the original, because instead of going up to 1 and stopping, these guys go to infinity. So when we do the inverse of it, our range is going to be from -pi over 2 to pi over 2, but our domain is all reals, because it goes on forever. So from -infinity to +infinity, and that's all reals. So that's how we have to limit these things. And remember, sine and tangent kind of act a lot alike for their periods, for their inverses, and the cosine is the odd one out. So the cosine, all right. So the composition of inverses, we've done the composition before. Let's take a look at how that's going to go down. If I have to find the angle whose tangent, because this, and arc tan of 0. So the, no, not theta, 0. The angle whose tangent is 0, if we go on our graph, remember, right there is where that happens. Now, if I was going to do the original tangent, it would be right there. The angle whose tangent is 0 happens at 0. Now, on this one, we can simplify because the arc cosine and the cosine are opposite operations. The thing that we have to be careful of is that a place where the arc cosine is defined? And in this case it is, because we know that it's defined from 0 to pi over 2, or 0 to pi. And so these guys are opposite operations of each other, so they just go away and you're left with pi over 8. Now we want to find the angle whose sine is negative root 2 over 2. Well, we know that that happens twice on my unit circle. And one of them is over here, and one of them is down here. So if on the unit circle that all these values happen twice, well, most of them happen twice on the unit circle, but we have to pick the one where it's defined. Well, if we remember where this one's defined is from negative pi over 2 to pi over 2. So the angle we pick can't be this one because that's past pi over 2. And when we pick our answer, we can't say, oh, this is the 7 pi over 4 because that's not where it's defined. It's defined at its coterminal angle of negative pi over 4. So even though they are the same address, same place on the unit circle, you have to use the right name. So let's take a look at this one. Now this one is not on the unit circle, 5/13. So the inside part is where we're drawing the triangle and making a triangle, and the outside is where we're going to answer it. So I'm going to go to my first quadrant where the cosine is positive, and I'm going to say the adjacent over hypotenuse. And I think this is one of the ones you would recognize. That one's 12. And then to answer the question, so we've set it up, the angle who has a cosine of 5/13, that's the triangle with the angle in it. And then we answer it by saying, what's the tangent of that triangle? Well, our tangent is going to be the opposite over the adjacent, and so that is the answer to it. All right, so there it is. Bring some good questions.